Okay, so today we're starting a new unit. Please look at your calendar and note that we have a quiz coming up on Monday. And as I'm going to announce to the class, you are welcome to use your notes for the entirety of the unit on your quizzes, on your test. You'll see it's a really long unit. There's going to be lots of stuff to keep straight. And then just to ease us into it, I'm going to allow you to do that. So today is the first lesson of the unit. It's about inverse functions because this whole unit will be talking about exponentials and logarithms, and they are inverses of each other. So this is a concept we will go back to frequently. A couple of things we learned in the past about things that pass the vertical line test. The vertical line test, remember, is where each x has only one y, and a vertical line intersects the graph at most one point. But today we're adding to that something called the horizontal line test, which is the inverse of that. Each y has only one x, and a horizontal line will intersect the graph through at most one point. And if a graph passes both of those tests, we call it a one-to-one function. Passes both the vertical line test and the horizontal line test. So practicing those ideas for this first section, this corresponds to your homework number 7 through 19. Determine whether the given functions are one-to-one. If not, explain why. If you're looking at number 1, if you imagine any horizontal line going through will pass it only one place. Also, any vertical line that passes through will pass it only one place. So we will just say, yes, this is one-to-one. Pause the video right here and try numbers 2 and 3 and before you unpause to see if you got them correct. So for number 2, I hope you got no, and the reason is because it fails the horizontal line test. And for number 3, you should have got yes. So that is looking at it graphically. This next section is finding inverses algebraically. An inverse function are functions where the x and y values are switched. I want you to look at this notation, the inverse notation for a function. So we're starting with a function f of x. Remember, f of x is just another way of writing y. Okay. And if we find the algebraic function of that inverse, this is the notation we use. F to the negative 1, meaning inverse of the original f. This does not mean f to the negative 1 exponent. It's just symbolic notation for inverse. And so here are the steps for finding inverse functions. Number 1, you use y instead of f of x. 2, you interchange x and y. 3, you solve the equation for y. 4, that result gives you the inverse function, and then you'll substitute this back in for y. So here's how that looks for this first example. Step 1, plug in y for f of x. Step 2, interchange x and y. Step 3, solve for y. So I do that by subtracting 3 from both sides. X minus 3 equals 2y divided by 2. Step 4, write the result, substituting f of negative 1x for y. This is saying that the inverse of the original function x is x minus 3 over 2. And just as a little self-check, this isn't a 100% rule that will not ever fail you, but as a general rule, if you look at the original function, 2x plus 3, and you look at the inverse, x minus 3 divided by 2, it's kind of like the operations have all been inversed, right? Instead of plus 3, we now have minus 3. Instead of times 2, we now have divided by 2. Again, that's not a 100% rule that will work every time, but at least you can sort of check your answer and see if you're off anywhere. Like if you had a plus in your answer, you might want to check yourself that you did your math correctly. So pause the video right now and you try number 2. So step 1, I replaced f of x with y. Step 2, I switched x and y. So it's now x equals y cubed minus 5. Step 3, I'm going to solve for y. I've added 5 to both sides. Now I have x plus 5 equals y cubed. How do I undo a cubed? I take a cube root on both sides. And the final step, the cube root of x plus 5. These cancel, leaving me y, but I'm replacing y now with the inverse function notation. In our little self-check, the original problem had minus 5. Our answer now has plus 5. The original problem had a cube. Now we have a cube root. So it intuitively feels like our answer is probably correct. On the back, we're talking about verifying inverse functions by something called composition. So I just told you in these examples that you can kind of, sort of, use your intuition to see if your inverse was correct. But what we're going to do now is I'm going to show you how you can actually confirm that algebraically by something called a composition. So a composition of functions means using one function as the input or x value of another function. So remember, if we have some function f of x equals x plus 2, and I ask you, what is f of 3? Well, that means you take 3 is now in the place of x, and so I'm going to substitute it everywhere I see x. And you would say f of 3 is 5. So in this situation, I used 3 as my input. Composition of functions means you're using a function as your input. Okay, and this is the notation. We write it 2 different ways. If I was using a whole other function called g of x, my input, it goes inside here. So instead of f of 3, I have f of g of x. Or you can see it written like this, with that little circle symbol. And here's the method for algebraically verifying inverse. You use the inverse function as the input for the original function, and vice versa. The end result should just be x, and that's because everything cancels out everything, leaving you just with the x left. Okay? So it says verify the inverse function from examples 1 and 2 above. So example 1, our original function was 2x plus 3. Our inverse function was x minus 3. We're going to verify this 2 ways. One is by using this as my input for this. And here's how that looks in symbol notation. Instead of f of x, I'm going to have f of negative 1 of x. Okay, that's my input. Which means I'm taking x minus 3 and plugging it in here for x. So I've got 2 times x minus 3 over 2 plus 3. The 2's cancel, leaving me x minus 3 plus 3, and the 3's cancel, leaving me just x. So that's check 1, that was correct. And now we're going to do vice versa. We're using this function as the input for this function. So 2x plus 3 is going to go right there for x. Okay, here's how it looks in notation. F of x is my input for f of negative 1, f of my inverse. And I take the 2x plus 3 and plug it in for x. Okay, order of operations, you're going to simplify that numerator first. So the 3's cancel, leaving you 2x over 2, leaving you just x. Okay, so that checks both ways. So I want you to pause the video. And for example 2, I want you to verify the inverse we got in the previous example. We had this as the original function, and this as the inverse. Pause and do your verification process both ways. Okay, here is where I'm going to do f of f inverse. So that means this is my input for this. So x is this, but I'm cubing x. So I'm cubing all of that, minus 5. The cube cancels out the cube root, leaving me x plus 5, the radicand. And the 5's cancel, leaving me x. So that's good. Now I do the inverse. I let f be the input for the inverse of f. So my inverse now is the original function. The original function was x cubed minus 5. It's now the input for this function. It means it goes right here for x inside the cube root. So I have the cube root of x plus 5. X is x cubed minus 5 plus 5. So working inside the radical first, because I'm doing my order of operations there. The 5's cancel. And now the cube root cancels the cube, leaving me just x. So that checks. So you can now do your homework. The key is in the back.